Hi everyone and welcome to the channel. Now today's video is one that I've been wanting to make for a really long time. We're going to be recreating my Windows 98 PC from way back at the end of the 1990s. Now I'd like a Windows 98 PC out on my retro desk as a sort of daily use retro machine, if you like, one that you can just rock up to and play on whenever you want. So I've decided to use that same hardware that I had back then purely because I know this is going to give me a big nostalgia kick. And although some of the parts won't be typical of some Windows 98 builds, lots of you will no doubt be familiar with them too. So I hope that you get the same big nostalgia hit from seeing these again that I know I'm going to get. So let me set the scene for you. My Windows 98 time went over two hardware upgrades. I originally started on an AMD K6-200 after upgrading from Windows 95. Didn't have that very long with Windows 98. Very quickly I upgraded to a K6-2 at 400 MHz, and that was what I had most of my Windows 98 time on. By the time I came to the second upgrade, it was the sort of very end of the late 90s, and me and my group of friends, we were all off to start on our own way in the world. You know, off to uni, off to college, into the world of work, whatever it was. But I still had my Windows 98 machine and it was still getting daily use. But when my friends and I were all in the same place at the same time, you know, typically over Christmas or over summer, whatever it was, we always found time for a LAN party together. Now sadly, these are some of the last LAN parties, or the last regular LAN parties that we had. So it's this hardware spec that we're going to recreate today. So if I had a K6-2, what CPU did I upgrade to? Well, it was one of these. A K6-3 at 450 MHz. Now that may not sound much of an upgrade on the surface of it. It's a clock speed jump of just 50 MHz, and a lot of K6-2s could have overclocked to that anyway. But it's important to remember that 50 MHz when starting at 400, it's still a 12.5% jump, even though nowadays 50 MHz doesn't sound like much. But there were some changes to the cache design on a K6-3. Now on a K6-2, you've got 64 kilobytes of L1 cache on die, you know, on the chip itself as it were. And your L2 cache, that was on the motherboard. Typically between 512 kilobytes or 1 megabyte, but it depended on the board. Now the K6-3, that retained the same 64 kilobytes of on-die L1 cache, but they added 256 kilobytes of on-die L2 cache. But the cache on the motherboard, that was retained as a sort of separate L3 cache, and up to 2 megabytes of that was supported, but again, it depended on how much was installed on the board. And you've got two advantages here. Having the L2 cache on die means it's closer, it's right there with the CPU, it's nice and fast, that's better performance. And with the L3 cache added in, your total cache is essentially larger, and typically larger cache, also better performance. Now you combine that extra L2 cache along with the 50 MHz, in my case, jump in clock speed, with the fact that you use the same motherboard, the same socket, same everything as the K6-2s, typically all you needed was a BIOS update, and you could see why this was an easy way to drop in a bit more performance into your PC. Now you may have spotted that this isn't just a plain K6-3, it's actually, you might just be able to see it there, it's a K6-3 Plus. The 3 Pluses were effectively a die shrunk version of the K6-3, so they ran at a slightly lower voltage and they ran a bit cooler, they have a bit more headroom for overclocking, which might be something that we'll look at in a future video. I think they also added a few more instructions to the 3D Now instruction set that's already on these. But I don't think those extra instructions were used for very much, so it's not something we'll worry about. But I have to say, I have a real fondness for these CPUs. These were the last AMD CPUs before the Athlons came along, and those slot A Athlons, they represented a kind of big jump onto the next generation. And it was a time when CPUs were moving technologically really fast. And these K6-3s, they were relatively short-lived. but they represented some of the best of the Super Socket 7 era, and for those reasons I really like them. Okay, so moving on to the motherboard, what are we going to put that K63 in? Now there are certain motherboards that have become really quite sought after for this Super Socket 7 era. Maybe for their features perhaps, or they're really good overclockers, whatever it might be. One of those motherboards is the Gigabyte GA5AX, and that's the motherboard that I originally had back then. Sadly I don't have one of those anymore, but if you have a look on eBay for example at the prices that the GA5AXs go for, you can see there's not many of them about and they're really quite expensive, so I don't think I can really stretch to getting one of those just specifically for this build. Now another one of those motherboards that's synonymous with the Super Socket 7 era is the ASUS P5A, and I do have one of those here. Now in many ways this motherboard is very similar to the Gigabyte GA5AX, but these P5As, they do have issues with some K62 Plus and K63 Plus CPUs. It depends on what revision board you've got. There's a very good thread on the Vogon's internet message boards about that, so if you want to learn more about that, have a search for that thread. This is a revision 1.3 board, and this one thankfully doesn't have any of those issues, so this is going to run our K63 Plus just fine. So let's take a look at it. We've got the socket 7 for the CPU, ATX power supply connector, 3 DIMM sockets, each one supports up to 256 megabyte DIMM. We've got the ALI Aladdin V or Aladdin 5 chipset consisting of the M1541 North Bridge and the M1543C South Bridge in this case. Again, different revisions of the ALI chipset can have their own quirks. I think this is a revision E. There's nothing too much that we need to worry about with that. The capacitors around the CPU socket, these boards are well before the capacitor plague, and although a visual inspection is no guarantee that the capacitors are fine, at least visually these ones do look fine. 512 kilobytes of what will be our level 3 cache, and then we've got 1 AGP slot, I think that's 2x, 5 PCI slots and 2 ISA slots with 1 PCI and ISA shared. A very sort of typical layout for the boards of this era. Coin cell battery, or battery holder in this case. I need to bob a battery in, but we don't need to worry about leaky batteries. Award BIOS chip down here, and then usual complement of ports, PS2 keyboard and mouse, a couple of USB ports, but they'll only be USB 1 or 1.1, something like that, 2 serial and a parallel port. At the back we've got 2 IDE headers. This is Ultra DMA 33, so we've got 33 megabytes per second theoretical transfer rate off those, and 1 floppy disk drive connector. Now that's not to say that these motherboards are perfect by any means. They do have some jumpers positioned in really awkward positions, like these here are right up against the DIMM sockets, and these ones here, you have a long graphics card or PCI card in here, they're obscured and you have to mess about moving cards if you want to change them. It would have been really nice if we'd have had a little block of dip switches on this board like a lot of competitors were starting to fit, rather than still using jumpers. But one good thing is that we do have lots of options for voltage to the CPU, for multiplier and for bus speed. So if we do look at overclocking in the future, and let me know if you'd like me to do that, at least we've got plenty of options to have a play with. But one of the best things for me about these Socket 7 motherboards was the shape of them. Daft as that sounds perhaps. They were really quite compact. They managed to get all the features in a sort of short space, and the second set of mounting holes, it's only just here, and the motherboard barely extends back from them, whereas typically nowadays your motherboards expand towards the third set of fixing holes, which is sort of back here somewhere. As a result, you're left with this kind of very long, quite thin rectangular shape. And for me, that's really iconic with the Super Socket 7 era. And that sounds perhaps even more odd given that we didn't have windows in the sides of your cases back then, so it wasn't like you could see them when they were in anyway. But nonetheless, I really like this, so looking forward to using this board. Now, moving on to memory, this is the first point at which I'm going to deviate from what I originally had back in the original PC. I can't remember how much RAM I had. Probably have been 32 megs, something like that. But nothing special here. We're going to go with two of these sticks. Now these are 256 megabyte sticks, so that'll give us a total of 512 megabytes of RAM. Now that's the maximum that you can use with Windows 98 without getting under the hood and messing about with some settings. But 512 megabytes, that's probably more than any Windows 98 PC would have had back then. And we're certainly not going to be limited in any way. We're not going to be swapping data in and out of RAM and to the hard disk, hitting the swap file, etc. With this much RAM in. So even though we could put 768 megabytes in, I'm not going to bother doing that. We'll stick with the 512 and keep things nice and simple. Now these are 133 megahertz rated sticks at cast latency 3. So since we're only going to be running them at 100 megahertz, we might be able to drop that cast latency to 2.5 or something like that. Maybe get a small performance increase as a result. But on the flip side, if we do try overclocking later and we want to push the bus speed up higher, we've got plenty of headroom to do that with this RAM, so this should be good stuff to use. Back in for a quick note, on AMD K62s and K63s, there is a bit of a quirk where you can actually take a performance hit if you load the computer up with too much RAM, sort of counterintuitive as that sounds. It's all to do with how much of that RAM is cacheable, and it depends on your motherboard, the chipset, the amount of RAM you're using and so on. Rather than listening to me waffle on about it, it's worth having a Google of that if you are running a K62 or a K63 with lots of RAM. The K62 Plus and the K63 Plus, they're not affected by that bug, so we can use all 512 megabytes without any worries. As for a cooler, nothing special here. We're not dealing with a lot of heat, so pretty much any cooler from the time period will be absolutely fine. I would like to put a reasonable size cooler on there, so we've got a bit of headroom for overclocking, but also for reasons that we can keep the fan speed nice and low and it's not going to be too loud. These two are a couple of socket 462 coolers and they're ideal for that. Socket 462 CPUs typically put out more heat, so these are fine for dealing with that. A socket 7 CPU, no worries. They do tend to be a little bit wider, a bit bigger though, so you've got to make sure you're clearing the area around the CPU socket, particularly on a socket 7 board. So long as you are, these will be okay. If not, I'll just get one that's a little narrower across this dimension here. I should have checked there wasn't any paste on that cooler before I put it down. Okay, let's talk graphics card. Now, most of my friends, they seem to have the more mainstream graphics cards, you know, your Voodoo 3s, TNT 2s, that sort of thing. I always seem to have something a little bit different. And so here it is. This is a Matrox G400. Now, I've always really liked Matrox cards. The first one that I had originally was a Matrox Mystique. Cracking 2D card, basic 3D acceleration, not particularly fast or fully featured, but the games that it could accelerate were really pretty nice. After that, I had a Matrox M3D, and even though that was a Matrox card, the tech on it was all Power VR, but that's another story. Following that, I had a G200. That was a solid card, fantastic for 2D, great for 3D and things like Direct 3D, but it was really let down by its OpenGL drivers. They were just not there, and Matrox messed about with those and lost a fair bit of goodwill, I think, with that. But following the G200 was this thing, the G400, and this for me was pretty much the pinnacle of Matrox's 3D accelerators. Brilliant 2D performance and signal quality, you know, and 3D performance, that was up there as well with the best of them. But importantly, the drivers for this were sorted, and didn't matter whether you were OpenGL, Direct3D, whatever it was, this thing could run it fine. Following this, Matrox had cards like the G450, the G550, but they were still heavily based on this at a time when technology was moving on, so they really sort of suffered performance-wise. And after that, Matrox had one final go at the 3D performance crowd with the ill-fated Matrox Parhelia. It was late to the party and performance was well behind the competition, and as a result it never really did very well. So whilst Matrox continue to make cards today, they don't make cards for gamers or for 3D acceleration, in a gaming environment, that kind of thing. Anyway, back to this G400. As I said, 2D image quality out of this was excellent, as was always the case with the Matrox cards. And the 3D performance, that was really good too. It was certainly capable of trading blows with the other cards, and when you went into 32-bit colour or really high resolutions, and this was often the fastest card of its generation. Now admittedly that wasn't for a very long time, because not too long after these cards were out, the first GeForce graphics cards turned up, and then we all know the story of what happens after that. Now the G400s, they had two main features that kind of stood them out from the competition. First one of these was they actually had support for two monitors from one card. Crazy, right? I know, driving two screens from one graphics card. I mean, it's done really often nowadays, we sort of take it for granted, but at the time it was pretty novel. Mainly aimed at kind of Windows desktop use, and it was all baked into the Matrox drivers, but it worked really well. And before that, if you wanted to support two screens, you would literally have to install a second graphics card into your computer and run one monitor off each card. Now I don't think it was actually used very much for a couple of reasons. As I say, it was mainly a Windows desktop feature, it wasn't really anything you saw in games or anything like that. But secondly, you would need two great big CRTs on your desk, and one CRT took up enough room, so I don't think there were many people putting two on there. But it was pretty cool nonetheless. The second main feature that it tried to make a sing and dance about was something called environment mapped bump mapping. Now at the time it was only available on these Matrox cards, and bump mapping, it's a way to make a sort of flat texture in a game look like it's got depth to it without going to the trouble of actually using lots more polygons to render a kind of, a bumpy surface, if you like. You're just rendering a flat surface with a couple of polygons and manipulating the texture to make it look as though it's got depth. Now there was already a way of doing this called dot 3 bump mapping, and that was pretty much card agnostic. It could run on most 3D cards at the time. But to be honest, it looked a little bit naff compared to environment map bump mapping. Of course, the problem with it only being supported at these cards at the time meant that there were very few games that supported it. But the couple that did, it looked pretty cool when it was turned on. It did come with a fairly big performance hit though, on the card, as these things often do. Now I'm not going to go into too much more detail about this thing. I think a lot of these Matrox cards, they've got an interesting story to tell, and they deserve their own video. Now the regular G400, that came in either 16 or 32 megabyte versions. I don't remember which one I had, probably the 16. But this isn't a regular G400, this is a G400 Max. The big giveaway is the fan covering the main chip here. It's basically a regular G400, 32 megabytes only, so we've got 16 there on the front and the other 16 on the back. But the core and the memory, it's clocked slightly higher than a regular G400. Now, even though this was only a small performance increase, the Max, one of these, this was always the card that I wanted. But my pounds and pennies could never really stretch that far, unfortunately. But I've had the opportunity to pick one up now, so this G400 Max is what we're going to use. Okay, moving on to the sound card. Now, unlike the graphics card where we all seem to have something different, when it came to sound cards, we all seem to have the same thing. And it's one of these, a Sound Blaster Live. Now these were the kind of next generation of sound cards from Creative, after moving on from Sound Blaster 16 and Sound Blaster AWE 32, 64s, that sort of thing. Now this is a model CT4760 and I think that's one of the original Sound Blaster Lives. I can't remember exactly what model number I had, but it doesn't really matter because within a range, the sort of core features tend to stay the same and it's just the extras around it that tend to change. But also, like a lot of Creative cards, different model numbers can sometimes have different quirks about them. So if you are going to pick one of these up, it's always worth a Google of the exact model number before you do. Now, one of the big features about the Sound Blaster Lives was something called Environmental Audio Extensions, or EAX. It was basically processing of sound effects to make them sound like the environment that they were, being generated in. So, usually used in games. So, for example, if your player was going down a long stone corridor in a game, the sounds might sound sort of harsher and more echoey, just like they would if you were doing that in real life. Now EAX, that was supported by lots of games and it sort of added a lot of atmosphere to them. It was really sort of quite nice to have. And it carried on being supported for a number of years. I think it all the way up to EAX version 5 eventually, well into the 2000s and beyond. Now that's not to say that these Sound Blaster Lives were the only sound cards out there. There were other sound cards based on things like the Aureal Vortex chipsets, for example. And it's also not to say that these were the best quality sounding sound cards. Now I'm not saying these things sound bad, far from it. They sound absolutely great. It's just that there were other sound cards out there that perhaps had even higher sort of output quality, of sound essentially. Now, I could never hear anything wrong with these back when I was younger, and I certainly wouldn't be able to hear anything wrong with them or any difference now. So a sound card like this, this will be absolutely fine. We're on to the PCI bus. This was that sort of transitioning point when sound cards were moving away from the ISA bus onto the PCI bus. Typical sort of complement of ports on the back. We've got a digital out, then your MIDI/game port connector down here, and then your usual sort of array of 3.5mm jacks, microphone in, line out for various speaker setups and so on. But it is not just the sound card. We have an add-on for it. And it's one of these things. A Sound Blaster Live Drive, or Live Drive 2 in this case. As you can see from the shape of it, it's an expansion board that sits in a 5¼ bay on the front of your PC. And it gives us a load more connection options to the sound card and relocates some controls to the front of the computer where they're easier to use. PCB inside, and then a great big long ribbon cable that connects internally to the Sound Blaster Live. Now, just like with the graphics card and the G400 Max, I always wanted one of these, but my pennies would never stretch far enough to get one. And even if I had have got one, I've got absolutely no idea what I would have used it for. And now that we have got one for this build, I've still got no idea what I'm going to use it for. Don't get me wrong, we'll find something to plug into it to give it a try, but I don't think I've got a sort of real use case for it. But you know what? None of that actually matters. I mean, just look at these things. They look so damn cool sat in the front of a computer that I just had to get one for this build. And so for that reason, and that reason alone, these things are worth having. Right, let's take a quick look at the network card. I don't recall what network card I would have originally had. It would have been whatever was the cheapest 10100 Ethernet card that my local computer shop had in stock. But for this build, we're going with one of these. It's a 3COM Etherlink 3C905. Again, 10100 Ethernet card on PCI. I've used these in lots of my builds before. They're nice and reliable, they've got good driver support, so they're a good network card to use. Okay, storage, and starting with the floppy disk drive, and yes, I am going to put a floppy disk drive into this build. It's a Mitsumi drive, lightly used, faceplates had all been cleaned up and retrobrighted, and it was working this when I last checked it. Now, it's probably not going to get much use, but for me, if we don't have a 3.5-inch floppy drive in the front of the case, then a build of this period, it just sort of doesn't look right for me. It's kind of lacking something, if you like. And likewise, when you switch it on, I like to hear that floppy boot sound, you know, the noise the floppy disk makes when it's seeking when the computer's first turned on. I know you can turn that off, make the BIOS boot quicker. Don't know why, I never did, but it's a sort of noise I've come to associate with old computers, and if I don't hear that, I'll be turning around looking at the computer wondering what's wrong with it. So yep, floppy disk drive it is. Moving on to the hard disk drive, and I'm a big fan of these IDE to compact flash adapters. Now, compact flash is pin compatible with IDE, so there's no conversion or anything like that going on here, which means these things tend to be pretty reliable. This one's mounted on a rear bracket, so got the compact flash card poking out the back of the case, and I find that useful to have because it means that I can take the card out and stick it in an adapter in the modern machine and image it really quickly, because let's be honest, we're dealing with the Windows 98 here, so the chances of it crashing and corrupting the hard drive, it's probably going to happen at some point. So just being able to stick the image back on the card and carry on from where we were rather than having to start again from scratch, that's a nice feature to have. Likewise, if you've got a really big file transfer to put onto the PC, again, just take the card out, stick it in another machine, transfer the files, bob the card back in. Okay, moving on to the CD-ROM drive, or drives as it is in this case. I'm going to be putting two in. I don't know if it was just me, but this seemed quite a common setup for that time period where you'd have a plain CD-ROM drive and then a CD-ROM burner, both in the computer at the same time. So you've got your standard CD-ROM drive. This is a Hitachi model. I can't remember if it's 52 or 48 speed, but we'd reached that point where CD-ROM drives were cheap and they're about as fast as they ever got. So, they'd reached that kind of ceiling of their speed, barring one or two notable examples. And when you were doing just, massive file transfers, so installing a program, for example, when you just wanted outright speed, you'd use your CD-ROM drive for that. And then paired with that in your machine, you've got your CD burner. This one's an A-Open. It's a 24 write, 10 rewrite, 40 speed read, although they never really seem to read perhaps as fast as you thought they should. But when it came to burning a CD, I'm sure there was some writing software that would let you take the data off one CD and burn it straight to a blank one, from one drive to the other without going via the hard disk. Whereas if you only had the CD burner in there, you're forced to read the CD, write it to the hard disk, and then from the hard disk back to a blank CD, which is a bit more long-winded way of doing things. It's a bit like when you used to have two floppy disk drives in a machine for copying a floppy disk. Now, like the floppy drive, both the fronts of these have all been cleaned up and retrobrighted to come up reasonably nice. So we'll get both these put in and we should be good to go. Okay, the power supply unit. Now, since this is a computer that's going to be out all the time and you should just be able to rock up to it and use it whenever you want, I want the computer to be nice and reliable, or at least as reliable as you can get for Windows 98. And so for that reason, we're going with a modern power supply. Now, this is a Silverstone model ST70F. It's a 700 watt unit, and that is completely overkill for a build like this, but it does at least mean we've got plenty of current available on the correct voltage rails. For a new unit, it's still got plenty of Molex and even floppy disk drive connectors, which you don't always see. And if you look at the ATX connector for the motherboard, you can see the extra 4 pins for the 24 pin version. They're completely removable, so even if your area around your power socket on your motherboard is quite congested, you can still plug these in. It would be nice if it were a modular power supply, but it's not like we've got a window in our case or anything like that, so all these extra cables, we can just bundle those up and tuck them out of the way somewhere. Here's the case we're going to be using. It's a completely sort of bog standard generic looking ATX tower case, and that's absolutely fine because that's exactly what I had back then. It's got no particular sort of standout features, all steel construction, a couple of 3.5 inch bays, three 5.25 inch bays, which was pretty typical for the time. I cleaned it up and retro brighted it about 10 months ago now, and it's come up pretty nicely. I think it's going to make a nice case for this build. Quick look inside the case, and the actual quality of the construction is pretty good. There's not millions of sharp edges on here to cut yourself on like you typically get on these cases. Now I'm not really surprised at that, because when I took it to bits, on the inside of the plastic front panel is the brand Enemax, who are a sort of quite well known case manufacturer. Doesn't say anything about a model number though, so if anybody does know what model this case is, please drop me a comment down below and let me know. I've done a couple of mods to this case. You may be able to see here at the back, I've cut the middle out of this 80mm fan location. It's one of those where it's just a load of little holes sort of stamped out of the metal, and that hardly lets any air through, so I've cut the middle out of that with a hole saw. Now I'll pop a fan grill over that so you're not going to cut your fingers on it. I've done the same down here for the front intake fan, and that one's got a magnetic fan filter across the front. I've also removed some of the plastic on the underside of the front cover, just so we can get a bit more air into the case. Now, as I said earlier, we're not dealing with particularly hot components, but nonetheless it is nice just to get a bit of cool air blowing across them. We are dealing with old components, so anything we can do to keep them running nice and cool, that's only got to be good for the lifespan of them. Right then, we've had a good look at all the hardware that we're going to be using that's laid out on the bench here, so that can only mean one thing. It's time for a build montage. Okay, that's the majority of the build done, and everything was fairly straightforward. Even though this is an old case, it was still reasonably nice to work in. The only slight niggle with the case is the screws for the expansion cards. They're kind of obscured by this thick lip on the back here, so you have to kind of get the screwdriver in at an angle that's a little bit awkward, but not a deal breaker, nothing too much to worry about. Couple of small issues. I don't have a cover plate for the second 3.5 inch front bay. I mean, you'll not be able to see it, but round there at the front, so that's just open. And I haven't really got one that matches, so we're going to have to maybe put another drive in there as a dummy or something like that. I'm not really sure what yet. It'd be a shame to waste something like an LS120 or a zip drive just kind of sat in there if it's not going to get a lot of use. But we'll have to put something in there, or at least find a cover that's a decent match to the case so we haven't got a hole in the front. Also, this Sound Blaster Live, I've noticed the PCB is a little bit grotty on this backside. Cleaned the live drive up and that's all come up nice, but that needs taking back out and a clean. we can sort that later, it's not a problem. This IDE to compact flash, that's not screwed into the slot yet, as you can see, and it's because this power cable for it is too short, it just doesn't quite reach. So I need to get an extension cable for that so we can get that screwed in. Now I could put it in a slot that's free, that's a bit higher up where it would reach, but I like to always kind of put that in the bottom slots. It means when the computer's under the desk or whatever it is, you can reach around the back and I know where the card's going to be. I'm not kind of fumbling around trying to feel the card to pull it out or anything like that. So just get an extension cable and that'll be easy to sort. Now along with this extension cable that we need for here, I haven't tidied up any of the cabling inside here yet, and I've deliberately done that. That's because I think it's time for a test, just to make sure everything's working properly. Just see if we can get to the BIOS screen and make sure everything looks like it should. Because one thing that might trip us up is that this motherboard, this graphics card and this sound card, these are all untested, or untested by me at least. When I got them all, I was told that they were working, and I've got no reason to believe that they're not, but it's still a little bit of a risk putting all the hardware in here before I've double checked those things. I realise it's tempting fate a bit, but what the heck, we'll switch it on and see what it does. So I'll get this thing connected to the monitor and we'll get a keyboard and hooked up and whatnot, and then we'll cross his fingers, we'll power on and we'll see what happens. Power supply on, fingers crossed, here we go. Not the best of starts, 3 beeps, 1 long, 3 short. And we are getting no display output. Let's just do a quick reset. Let's, all I've done is take it out, reseat it. Let's try it again. No! Okay, I've put a TNT2 M64 in there that I know works, so let's try that again, see if we get anything now. Yep, straight away, look. MMX 450 MHz processor. Only half the RAM is showing up. Well, at least everything else appears to be working. I don't know if that is the latest version of the BIOS. It might be worth putting the latest version on and trying that graphics card again before I start dragging another computer out and putting that one in to try. So yeah, quick update on the memory. You see there we're only detecting 128 megs, and that's because I've taken one of the 2 DIMMs out. Now the 256 meg DIMMs, here's the one I've taken out. I hope that's in focus, but you can see we've only got chips on one side. I think as a result of that, it's only detecting half the capacity. The manual may have said something about that, I can't remember. Not a problem, we'll put the latest BIOS on, see if that changes the behaviour of that. I don't think it will. And then we can either put all 3 of these in and get 384, whatever it is, megabytes, or I'll have a dig through the box of old RAM that I've got and see if we can find some double-sided 256 meg DIMMs instead. Okay, quick update. I've updated the BIOS to the latest version, and as we can see our K63 CPU is now being detected correctly, so that's all good. And credit to ASUS, this BIOS is still hosted on their website. A quick Google search found it. That was nice and easy, so well done there. I've also swapped network cards over. I didn't realise, but I'd accidentally grabbed a network card with the boot ROM on it. And that boot ROM, it sort of kicks in before the PC tries to boot off floppy drive, off hard disk, off CD, whatever it is. It allows the network card to boot the computer remotely, do network management and administrative type stuff. You can even run with the hard disks on a server somewhere with no hard disk in the machine. All cool stuff, but not something we're really interested in this video, so I've taken that out and put it in for another exact same model, another 3C905, but this one hasn't got a boot ROM on, so it just behaves like a plain network card. And also, our G400 Max, it's in and working seemingly. Now, I don't think the BIOS update's got anything to do with that. What I think it is that this bracket here at the back, that, or the sort of casework around it, is a little bit bent. And when that was getting pushed in and screwed down, the back of the card was just kind of lifting out the AGP slot a little bit. There's no retention tab on the back of this AGP slot, so I think it was just lifting up and failing to make contact, especially since AGP slots have to be quite precise given that sort of double layered pattern of contacts that they have. It's not just a straight set of edge connectors like you get on, say, a PCI card, for example. Hopefully it's just that. If that's all it is, that's easy solved. I've made a bit of a tweak to the bracket there, so that, touch wood, that'll be okay. If it starts going flaky and it turns out it's more of an electrical problem, for example, with the card, that might be a bit trickier to solve. But yeah, so far so good on that one as well. So now that everything seems to be going well, I think we're going to leave it there for part one. In the meantime, I'll sort these cables out and do something about the hole there in the front for the second 3.5-inch drive. And then we'll come back in part two, we'll install the OS, and we'll install some software and some games and whatnot that we all remember from back then. And we'll have a play around with them, and hopefully that'll sort of give us the same nostalgic kick from the software side of things that we got out of this hardware today. And I have to say, it's been really nice getting hold of this hardware and putting this system together. It's nice to put a system together from time to time where this hardware is going to stay together for a while and this system is going to see a lot of use. As opposed, I guess, to sort of putting a load of hardware together just for a single purpose. Like the overclocking build-off video from 2-3 videos back, where a load of hardware was assembled, we did something cool with it, but then it all gets taken back to bits and either used for something else or put away. This is the other side of the coin, where we're putting it together and building a system, we're leaving it together to use. So I really hope you've enjoyed this video and looking back at this old hardware with me. If you have, drop us a comment down below or leave us a thumbs up, all that sort of good stuff. But for now, I'm just going to say thank you very much for watching, and we'll see you in the next one. Bye bye.